And I'll tell you when I finish doing the part that we're going to do, what happens after that, although we're not doing that, okay? That's something you'll pick up junior year in your next algebra-related class, okay? So what is linear programming? This is a really, really, really good application to solving inequalities, okay? A mathematical model used to maximize, usually profit, or minimize, usually cost, to minimize or maximize something, okay? We're going to do two parts of this. We're going to write the objective function based on the word problem. The objective function is an equation. Remember that an equation has an equal sign, so that's important. To find the value at each corner point, this determines the maximum or minimum. Now, that definition, I'll kind of explain a little thoroughly after we do what we're going to do, okay? The constraints are the inequalities, and this is where inequalities come in and why it's part of Goal 9. Inequalities that describe the limitations or constraints of the problem. Every problem includes the constraints x is greater than or equal to 0 and y is greater than or equal to 0 if they are not assumed within other inequalities. That's really important, and I'll explain that as we go, but that's really, really important. This definition, you might want to look over that a couple of times, okay? All right, so this is the kind of word problem we have. Now, I will just tell you that you probably wouldn't literally use linear programming to do this. I'm sure our athletic association here does not use linear programming to figure this out, okay? But this gives you a good start in understanding what process you use to do this, okay? So it's kind of a simple question with some results that you really wouldn't use this for, okay? All right, a snack bar cooks and sells hamburgers and hot dogs during football games. To stay in business, it must sell at least 10 hamburgers, but cannot cook more than 40. It must also sell at least 30 hot dogs, but cannot cook more than 70. The snack bar cannot cook more than 90 items total. The profit on a hamburger is 33 cents and a hot dog is 21 cents. How many of each should it make to maximize the profit? What is the maximum profit? All right. The numbers in the question that deal with what you're trying to do. What is the objective function? What are we trying to do with the question? We're trying to maximize our profit. So the numbers from the question that deal with maximizing profit go into the objective function, okay? Essentially, when you finish this, you would be graphing. We're not doing all of that, but you're graphing. So you need your x and y. So I'm going to let x be the number of hamburgers and y be the number of hot dogs. So in my objective function, okay, remember what I'm trying to do is maximize my profit. So my profit would be 33 cents for every hamburger that I sell, 21 cents for every hot dog that I sell, for a total, oops, forgot my x, of 21 cents, or a total of t, sorry. 33 cents for every hamburger, so 33 times x, plus 21 cents for every hot dog, 21 times y, equals my total profit I'm going to make. Always write your objective function first so that you can get those numbers eliminated from the rest of the thing, okay? Again, the objective function is something we would come back to at the very end of the whole process, once we would do the whole process, if we were going to, okay? All right, now the constraints. The constraints are the inequalities that describe the limitations of the problem, of the stuff going on, whatever is going on in the question. So it says, to stay in business, it must sell at least 10 hamburgers. So that tells me that x should be greater than or equal to 10. At least means that or more, so greater than or equal to. But it cannot cook more than 40. So at the same time, x has to be less than or equal to 40. Okay, so I've used that number. You've got to make sure you use all your numbers. It must also sell 30 hot dogs, at least 30 hot dogs. So y has to be greater than or equal to 30, but cannot cook more than 70. So that's the most I can do. y is less than or equal to 70. I'll get you, Caleb, just a second. The snack bar cannot cook more than 90 items total. So total hamburgers and hot dogs all together, which means adding them has to be less than or equal to 90. Caleb, your question.
So could you like put the x is...
I know what you're going to ask. I already know what you're going to ask me.
To a string, I guess.
Yes. To a combined inequality. Yeah. Caleb's question, which I didn't even let him finish because I could read his mind. That's a scary thing, just so you know. Okay, so greater than or equal to 10, less than or equal to 40. Can you write this as a combined inequality? Certainly. Okay, so it can be separate or combined. It doesn't matter. Okay, so I've exhausted every number in the question, so I know that I'm done here. I know that I've written everything that I think I can write. Okay. Remember back from the thing above that I said read this over again? Every problem includes constraints that should have x is greater than or equal to 0 and y is greater than or equal to 0. Every problem has to have that. However, in this particular one, it says that x is greater than or equal to 10. So that makes it bigger than 0. So we don't have to write that constraint. And it says y is greater than or equal to 30. So we don't have to write that constraint. Okay? But those two, x is greater than or equal to 0, y is greater than or equal to 0, have to be part of every problem. If they're assumed within another constraint, you don't have to write it though. Okay, so this is what I mean by that. If it says x is greater than or equal to 10, it's assumed that it's greater than or equal to 0. Okay? That's all we're going to be doing, just writing that stuff. But I want to talk real briefly, shortly, about what would happen at this point. Okay? If you were doing this question at this point, if you were going to continue, we would take this, we would go to our coordinate plane, and we would graph it. Okay? So this is the process that you'll continue on in your next algebra-based class. You would graph all these constraints. So I'm going to go down here to the bottom real quick and just sketch something. And so you would have something that looks like this. I got to think how that's going to go. That's higher or lower? I think it's higher. Something like that. And remember, we just did shading on our assessment, and our shading would take place in there. Okay? So what that tells you is that the maximum profit happens somewhere here, somewhere along the boundaries or within the shaded region. Okay? So this is how this shading of inequalities builds from what we just did. Okay? So then we would take off the corner points because there's an infinite number of points. We would use our corner points. And these are XY coordinates, which remember, the XY coordinates that they represent hamburgers and hot dogs. So we would take those XY coordinates, we would plug them back into the objective function to find out which pair gives us the biggest profit. Now, I've done this question before, and it's a whopping $23.30 or something like that. So that's what I mean by, wouldn't really do that kind of question, okay? We're going to see some questions, though, that are really, really business related. This is a real thing. People really do this stuff. And possibly the computer generates some of it, but it would never generate this part. This part that we just did, you would have to know. That's the stuff that you would have to come up with, okay? Questions so far? So you're turning the words into inequalities. The next one's a little trickier. Waldo's Biscuit Factory makes 2 types of biscuits, jumbos and minis. The oven can cook at most 200 biscuits per day. Jumbos each require 2 ounces of flour. Minis each require 1 ounce of flour. There are 300 ounces of flour available. The income or the profit from jumbos is 10 cents. The income from the minis is 8 cents. How many of each type should be baked to earn the greatest amount, and what is that amount? So again, we're trying to make some money. We're trying to maximize our profit. So these numbers that deal with profit are going to go into the objective function. So I'm going to let X be jumbos and Y be minis. The objective function is probably going to be the simplest part for you. So the income from jumbos, 10 cents times every jumbo biscuit plus 8 cents times every mini biscuit equals the total amount of money that I would make. That's my objective function. Always an equation. Now my constraints, and this is where it's a little trickier than the last question. The oven can cook at most 200 biscuits per day. It doesn't specify what kind. So total 200. So jumbos and minis together. X plus Y less than or equal to 200 at most. And then this is the tricky part, which we'll kind of hit on again in another question here in a little bit. But jumbos each require 2 ounces of flour. So sometimes people want to put for that question, X is less than or equal to 2. But think about what X means. X means the number of jumbo biscuits. So it wouldn't make sense to say that the number of jumbo biscuits is less than or equal to 2 ounces of flour. Doesn't make sense. Okay? So you're going to take all the information about flour and it goes into one constraint. Okay? And after I write it, I think it's going to make sense to you. Okay? So I'm going to use 2 ounces. So that becomes my coefficient. For every jumbo biscuit, 1 ounce for every mini biscuit, and I have equal to 300 ounces of flour available. So we can see how that went together. So flour, 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 it's all about the flour. So one constraint dealing with all of the flour. Okay? I've used all my numbers, so I can't take anything else from the question. But I go back to what I said up here. Every problem includes the constraints. X is greater than or equal to 0, and Y is greater than or equal to 0 if they are not assumed within another one. They're not in this question. It doesn't tell me that X and Y, or X or Y, is greater than or equal to 0. So for this particular problem, you're going to have that written. We're never going to have negative stuff, whatever we're working with. In this case, biscuits. We can't have negative biscuits. That's why my X and Y are always greater than or equal to 0. Every single question. Okay? Okay, a question there. Yes, sir.
Do you want us solving these on this?
Nope. That's all you're going to do. That's all we're going to do is just write them.